Hey everyone, welcome back to the channel. I hope you guys are doing all well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So today's challenge is a pretty simple one. Minimum ASCII delete sum for two strings. You are given two strings s1 and s2 and return the lowest ASCII sum of the deleted characters to make the two strings equal. Okay. So you are given two strings. You want to select some characters from the first string as well as the second string and you want to delete them such that the sum of the ASCII characters, okay, ASCII value of all the characters which you delete, that should be minimum possible, and at the end, after deletion of those characters, both of the strings should be equal to each other. Okay, so if you see for the first example, the first string is given as SEA and the second string is EAT. So if you remove S from here and if you remove T from here, you both of the string becomes equal, right? They become EA. And what is the ASCII value of S plus the ASCII value of T? This will be our answer because that is the minimum possible. So ASCII value of S is nothing but 115 plus 116 for T, so it will be 231 is your answer. Okay, so and if you try to select this delete and lead, okay, try to see this for the next example. uh, Delete and lead, so you have this delete as well as lead. Okay, so you want to delete some of the characters to make both of them equal. So if you choose to delete this one and this one as well as this one, let's say both of them becomes let, that is they both of them become equal, and what will be our answer will be nothing but d plus e plus e plus e, the ASCII value of all of this. If you add, so if you happen to add the ASCII value of all of them, you get 403. Okay, you get 403. But if you try to do something else, so if instead you try to turn both strings to LEE or LEET, you will get an answer of 433 or 417, which is not the minimum possible. Okay, so yeah, so the minimum possible one is 403. So that is what I hope the question, at least it is very clear, and by looking at the question as well as the constraint of 1000, you can get an easy idea that this is a typical DP problem. Okay, and LCS kind of DP you can call it, and you want to select, you want to keep two pointers. Okay, so let's say delete and lead. I will take this example only. So you want to keep two pointers, pointer I, which will be pointing to the first string, first character of the first string, pointer J, which will be pointing to the first character of the second string, and you iterate them in every recursion call. So you will try to basically first write a recursive solution and then convert that to recursive DP, or memoize, or we call it memoization. Okay, so yeah, if you do this, this will be an accepted solution, and in my DP playlist I have in detail also explained how can you write an iterative version of this also. So you can go forward for that, but we will discuss these two approaches today. So if you see that I is initially 0, J is initially 0, if you see that, hey, both of these characters are different. Okay, so you have many choices. Okay, so you can choose to delete this, that is you can increment I. Okay, so you can skip S1, skip the index in S1 and then move I. So in that case I plus 1 will be happening. Okay, and if you choose to move J, then J plus 1 will be happening. So let's say for instance you choose to move only I plus 1. Okay, so right now what is the scenario? I is pointing over here, J is pointing over here. Okay, and now you see both of the characters are equal, so you do not need to delete anything. You can simply increment the I and J both. Okay, so if again, if you can call it like S1 of I is equals to S2 of J, then you can call return simply, let's say that whatever recursion function you are calling, uh, I plus 1 J plus 1, you can just increment that those and simply return that. Okay, so you see, right now again if you try to see delete, J I will be pointing over here and EAT J will be pointing over here, and similarly you can just go ahead. And one thing is there, when you choose to skip D, you not only increment I plus 1 but you also add S of I to your answer. If you are skipping S1, then you must add this ASCII value of D to your answer, right? And yeah, so I hope this is at least quite similar to this take not take kind of DP only, where you are choosing to skip the character or not skip the character, and whichever will give me the minimum sum, I will just return that. One edge case which you need to think about is that what will happen if you reach the end of one string while the other string is still not reached. Okay, so let's say in this example only delete and lead. Okay, you do understand that, hey, at first you are here, then you match these two E. Okay, and then you move forward, right? Move forward. So uh, I consider delete and eat and not delete and lead. Okay, so here let us consider delete and lead because this example has an edge case. Okay, so what will happen in this case? If you see, one at one point you will reach this T and you will reach this T. Okay, then what will happen? So it might be also possible this character has some XYZ and stuffs like that, but you have reached the end of one string, and then what is going to happen to the other string? All these characters, you have only one choice. So far you are taking the choice whether to delete the character in S1, skip the character in S1, or delete in S2. Okay, you are taking these two choices, but once you have reached the end of this T, do you think you have any choice left for all these four characters? You have to perform deletion for all of them. So there is only single choice for all of them. Okay. So this thing you need to separately handle. In the base case only, when you write the base case, then only I guess you can just iterate through the remaining characters and add the ASCII values to your answer. Okay. You can simply do this. I hope it is very clear, and we can try to start the coding portion. So we have, let's say I will write another function which will take these two strings only, and these are nothing but the two indices I and j, which starts from first. Okay, which starts from first. So we have this function. Let me write the function definition: string s1. We have string s2, int I, int j. Okay, so yeah, this I is the iterator for this S1 and J is the iterator for S2. Okay, I hope there is no doubt in this. And first comes obviously the base case, and in that base case only this edge case you need to handle. So what if in the first case is that let's have this n and m. N is nothing but the size of string S1. M is nothing but the size of string S2. And if you happen to reach I equals to n, that is the first this iterator reaches the end of the string, but this iterator is still remaining. So for all those remaining cases, there is only one choice for you. Okay, there is only one choice, that is you need to delete all the characters. Okay, so you can just keep int s1, and while this j is less than m, you can tell it like that. What you will do is plus equals to s2 of j. Okay, s plus equals to s2 of j and j plus plus, and you can choose to return this s, because that is the remaining ASCII value after deletion of all the characters. Okay, similarly you can write the case for j equals to m. So if the other character reaches and this character does not, things will just get reversed. uh, this will be s1 of I and I plus plus and return s. So these are the two base cases which you need to take care in this problem. And one very obvious thing which we will write now is s1 of I. If both of characters are equal, s2 of j. Okay, then we have our favorite thing to do. We can just go ahead by incrementing I and j. Okay, we do not need to think anything in this case. I and j. And what if they are not? You can choose to skip the character in s1 and s2 one by one. So skip s1. What is the answer obtained after skipping s1? This is telling you what is the answer obtained after skipping s1. uh, it's simply, if you're choosing to skip this s1, it will be s1 of I. You just add this ASCII value and j. Okay, and simply in a very similar manner you can choose to skip s2, then it will be s2 of j and uh, this I j plus 1. I hope it is very simple and not at all dubious. What will you return is very easy. You will simply return skip s1 and skip s2. So minimum among all of these, because you need to find the minimum. No need to complicate anything. This will should give you the correct answer. You see, we get the accepted thing. If you try to submit this, this will give you an obvious TLE because we have not yet memoized it. So yeah, you can go ahead with writing the DP solution. This will give you a TLE. Because yeah, I hope you know that recursive is a exponential time complexity. So if you draw the recursion tree, there many states will be repeated. So what we try to do in this recursive tree, we try to catch the values. So we try to meme set dp with -1 and size of dp. Okay, and once you have this, what you will just check is that if -1 represent an empty cell. Okay, so if dp ij, okay, if ij is not empty, that is if it already has some value. So if dp of ij is not empty, you can simply return dp ij. Okay, and if it is empty, you go ahead and calculate these values, and also you should store whatever you found after calculating. Never forget to store, because you are sort of acting as making it act as a cache memory. Okay, so dpij, and again very similarly you can write dpij here also. Before every return statement you need to save the state. Okay, you need to save the state of the dp. This way we will ensure that we do not do any duplicate calculations. Okay, so I have explained this in detail in my dp playlist. You can just go through this if you are not very sure. Otherwise it is a very standard template for recursive dp, and that's why I call this problem very easy, because uh, just a standard procedure which you follow. Okay, so if you try to submit this time, it should work just fine. Yeah, you see it's working just fine. If you want to optimize it further, you can definitely write the iterative solution. Otherwise, in normal CP, you can just simply write this recursive, but in interview they might ask you to write the iterative solution. So you must also prepare this method. For more info, you can definitely go to my DB playlist. I hope the problem and as well as the approach is very clear to you, and there is no doubt about that. So yeah, that's all. That's all for this video. I will meet you in the next video. Till then, thanks a lot.